Okay, so to start with, we have to know what strain is all about. Why is it that this is represented by uh, an alternate, okay, a strain measurement on the either side? So the reason for that is because flexural behavior introduces a reversed, okay, a type of stress, which is positive uh, on one side and negative on the other side, or vice versa. So this is just the tension, sorry, the compression side and the tension side. So and the fact that the principle of compatibility, when you say compatibility, is actually assumed in this regard, then this happens to be a straight line. Okay, if compatibility of strain is represented by a line which is not straight, then small deformation theory is not taken into consideration. Okay, but this happens for some cases or scenarios wherein walls can behave that way, deep beams can behave that way, and vice versa. But for beams, as defined on the basis of ACI code, this is fairly linear. The linear assumption is fairly acceptable. Now we go over to the stress assumption. So what we have here is an approximation normally, as stated on the ACI. There's an approximation of a rectangular stress block pattern, which is introduced earlier on the earlier uh, concepts of reinforced concrete by Whitney. Okay, so this is what you call the Whitney's rectangular stress block that made the computation simple as compared to using an actual nonlinear stress block, which is almost parabolic in nature. And our consideration for our discussion is on this particular curve, which is nonlinear or actually parabolic on the basis of the PCA stress distribution. And there are a lot of models that you can uh, look into, no? So when you type the internet, you can look into the lot of models, but of course, since PCA and ACI work hand in hand in uh, terms of research, no, in terms of developing a lot of equations, no, to address the concern of concrete behavior, then we use PCA as uh, uh, our model, no, in this particular presentation. Okay, so in your lecture in the lecture that I gave you last time, we have discussed some mm, uh, definitions on curvature, etc. Okay, so we proceed with the steel property as one again of the assumptions needed to complete, no, the formulation of the equations for flexure. So the assumption is that steel is elastic, it's an elastic, perfectly plastic material. So this is actually the basic plot of your coupon test for a particular steel bar, which is subjected to axial tension. Okay, so you have here the elastic, the plastic stage, and the strain hardening stage, which actually start to begin from the time the yield strength increase, no, up to a value, let's say ultimate strength, before it drops suddenly into a rupture strain. Actually, class, this only happens. So why is it that there's a sudden drop? Actually, the curve is not will not drop if we only use the area that the actual area that is manifested, uh, taking into consideration what you call the necking, okay? Because the necking area is not the one considered in your computation, then of course the tendency for the stress is to drop. But if you are considered the necking area, which is smaller than the actual area, initial area, then this will actually be uh, uh, what still increasing, if not maintaining its what you call the ultimate or the yes, the ultimate stress given by the variable Fu. Okay. So the third assumption is now on the concrete stress distribution, which simply states that the distribution of the internal stress must follow whatever the distribution of the stress strain test is based on the cylinder strength, which happens to be a standard okay uh, sample with a diameter of I think 6 inch and a height of 12 inches. Of course, if these are violated, then some correction factors must be inputted, no, just to see to it that we do not deviate from the assumptions, uh, which are, of course, the basis of a code known as the ACI. And why do I talk of ACI always? Is it's simply because the NSCP is generically an ACI uh, code. Okay, so we are actually adopting the American code as our mother code, lalo na do sa mga parts, mga sections na wala tayong maraming studies na nagawa, wala tayong magagawa kundi to depend, no, on other codes and make it appear na applicable sila dito sa ating bansa. Of course, kayo nang bahalang mag-isip kung tama ba yon o mali. Okay? So, maximum usable strain is 003. Note that the epsilon Cu may reach 008 due to the stress redistribution. So, this is the ACI again, the ACI assumption. Of course, if you are using the British standard, okay, the BS or the British standard, they use I think 004 or 0045 as their ultimate or maximum usable strength. And it can reach 0.008, but this is very dangerous because this is only due to what you call stress redistribution. Itong stress redistribution, ito yung huling pamamaalam nung material mo no. Pero kaya hindi mo na dapat isama ito. Napaka delikado niyan, no? So, mas maganda you only stick with 003 or maybe 004 if you want to adapt the British standard. Okay, so this is a typical strain distribution. So I discussed to you on that video what the assumptions are as converted or transformed into what you call equations of compatibility, stress, and the last thing to do is, of course, to see to it that the internal components of your material are within the equilibrium stage. Okay, so you just apply the equilibrium equation, and at this point, we have to start doing some mathematical interpretation of the PCA curve. Okay, so medyo pagdating dito nag-iiba yung yung simple assumptions of Whitney compared to the PCA assumption, or maybe another model. I think this is the Hagstad model, which is same in nature as that of the PCA, but some drop on the stresses are made available within the range epsilon C to epsilon CU. Okay, and this is your assignment, class. Okay, so ano sabi natin? We have to see to it that this stress strain distribution or stress strain plot will be the basis of your internal stress diagram. Okay, whatever is the shape of this graph, the actual, the PCA, or the Hagstad model, you have to reflect it on the stress diagram here to determine the stress block parameters known as K1, K2, and K3. Okay? So what are K1, K2, and K3? K1, K2, and K3 are simply the parameters that you need in order to locate, or sorry, to determine the magnitude and locate the centroid of your stress block. And in this case, since this is parabolic, it's not as easy as getting the centroid of a rectangle. Okay. By the way, there's a very small error, but very important. This rectangle does not lie. I think I have not corrected it last time. Does not lie on the neutral axis. So this is the neutral axis, class. Slightly, kung makikita niyo yung mga computations natin sa college, no? Yung stress block natin na rectangular, nakaangat yan. Ito yung A mo, no? Ito yung A. Okay. And the centroid of A is simply at A over 2. Okay? So, A over 2 yung centroid. Ano ngayon yung K2? So, K2 simply means that this is A over 2. A over... Sorry, not A, but beta 1. A is the counterpart of your dimension KD depth. So, magiging siyang beta 1 over 2. So, ito yung K2 mo. K2, KD siya dito, di ba? So, C is the counterpart of KD in strength design is C. That's why, if you will want to get K2, K2 is simply beta 1 over 2. And K1, K3, as I discussed in the lecture video, is your LO. And you cannot separate this. It's very difficult to separate it because K1 has something to do with the approximation of your tip, the tip of your stress distribution there, and the coefficient that concerns proportionates the area of the rectangle. So itong K1, K3, mahirap paghiwalayin yan, class, no? That's why pagdating natin doon sa PCA, napansin nyo, LOL1 tayo, no? LOL1 yung parameter natin, tapos relate natin yan dito. Okay? So I don't know if I have a video on the discussion on this to further explain it, but I know that you can understand what I mean right now if you can follow the concept I'm trying to discuss. Okay? In case you have some confusions, don't hesitate to ask me. And these are the short lecture videos I really wish to share to you on my YouTube channel. Kaya lang biglang maraming ginagawa talaga sa school, kaya hindi ko mabigyan ng time yung pag re-record, no? But in case I have time, these are the things that I'd like to share to many civil engineers na hindi nila masyadong nalilito sila. Hindi nila naintindihan pero kung minsan nakakalito. Just like when I was still studying, I really have a lot of questions to ask to my professor then pero nahihiya ako kaya paulit-ulit basa lang ng basa hanggang mapagdugtong-dugtong ko lahat yung ibig sabihin at ito magkakadikit lahat yan class. Okay? So on my video, I also discussed to you what the sectional capacity is, how it is being determined on the basis of a very irregular section here. Okay, so imbis na pag-aralan mo yung T-beam, rectangular beam, triangular beam, lahat ng beam, doubly reinforced beam, isama mo pa. Isa lang yung ating procedure diyan. The intention and the concept, the fundamental principles are just one. So if you understand here, up to the point na gusto mong i-translate it into a rectangular stress block, wala kang gagawin kung hindi convert mo lang yung mga parameters na to, no? So I will not discuss it to you here. I also discuss how the actual section is transformed into a what? A natural section. So this is the actual coordinates. You call this now the actual parameters or the actual coordinates. When you talk of geometry class, coordinate and geometry are just one. No? In the master's degree, you will not be using shape, sections. The words are a little bit different. No? You are using more on the coordinates. When I say coordinates, it's the geometry, it's the shape of the section. So the actual coordinates is actually converted into a natural coordinates. And I already told you the reason why it's called natural coordinates, because we are now to anticipate our differential equation to be converted into a simple natural xy coordinate. And that's why this is in natural coordinate, including the limits converted into a 0, 1 unit. Okay? So, madaling mag-integrate, madaling mag-differentiate, madaling kumuha ng area kapag rectangle. Diba? Madaling mag-multiply pag 0 and 1 lang. Madaling mag-perform ng mathematical formulation pag 0, 1 lang ang limits mo. And this is the reason why we transform the actual coordinates into a natural coordinate. And this is how a program works. Okay? This is how a computer program works. A computer cannot define the geometry in terms of a description or tracking without using vectors or coordinates. Okay? Mababasa lang yan pag nalaman niya yung shape nito. Equations, hindi rin na nababasa ng computer yan because mababasa lang yung equation pag kinonvert mo na ng data points. Okay? So, kaya napaka-importante ito. Maintindihan nyo yung procedure on this transformation, especially when you take a subject, another subject which is very important, yung finite element analysis subject. Okay, so let's move on into the compressive strength, how to get the internal forces. You call this the internal forces, and the internal forces is simply a formula. A force is simply a stress. This is stress multiplied by the area. Okay, this is a force. F. Okay, kaya lang integral siya, no? So dito niyo nababalikan yung integral calculus, yung pag-i-integrate niyo na sabi niyo medyo hindi niyo makuha yung same answer, pero not necessarily hindi tama yon, baka hindi lang ganun yung form. Okay, so to answer the comment of one, I think that's Alan, i-try nyo na i-substitute ng value kung pareho yung makukuha, ibig sabihin, the equations are equivalent. Okay? You just try inputting a value and then if the equation are equivalent, then there's no problem with your answer. Parang ano lang yan eh, no? Hindi naman tayo mathematicians para i-fit natin talaga yung particular answer. We can do it, but it's a waste of time and effort. Huwag naman nating ubusin yung time natin. No? Pero kung ang problema nyo is how to do it, may problema kayo doon. You have to understand
integration.
how to do it. Okay? Yes?
Hindi naman po siya sa integration part na nahirapan. Yung form lang talaga yung gusto makuha.
Okay, yung form walang problema doon, Alan. As I've said, you just check it kung tama yung result mo by substituting a value on the parameters. Tama? Kasi parang na-encounter ko rin yan, no? Na-encounter ko rin yan. Hindi ko makuha yung tamang form, pero pareho lang pala siya.
Okay, sir.
Okay? So, yun na lang i-check mo. Kung tama yun, walang nabawas dun sa correctness ng problem, ng solution mo. Okay? But for the others who are finding it hard to integrate, medyo ibig sabihin, konting review lang dun sa integral calculus natin. So, ito yon. Diniscuss ko na to. I don't want to go back to it. Parang hinimay ko lang. Ay, ito na, no? Dito na papasok. Ano yung K2? So, K2 is 1 L1 over LO. Kung gusto nyo itry kung paano makuha yung sa Whitney, substitute lang si L1 tsaka LO kung magpapareho siya sa beta 1 over 2, etc. Okay, so, this is a PCA stress block. Ito yung sinasabi kong i-integrate nyo later na by imposing epsilon here as your variable of integration. Okay? So, case 1 and case 2. Ito na yung mga sabi ninyo na hindi pareho pero baka they are equivalent. No? Yung form dito. Yung dalawa ba, Alan, ang hindi pareho? Hindi nagpapareho.
Yung sa case
1, okay siya.
Parang po.
Okay, yung case 2 medyo hindi pareho. So try mo lang i-check.
Okay po,
Try
sir.
mo lang i-check. And also try to kung yun yung mga gusto kong i-discuss ninyo dun sa inyong. By the way, for those who are not yet around, what is important in your assignment are the comments and interpretation and not the formulation, no? Hindi na ako masyadong hindi ko na tinitignan kung ano yung mga doon. Nang gusto kong makita yung comments nyo dun sa huli. Okay? Because these are just figures. Kung walang mag-i-interpret niyan, walang kwenta yung mga figure na yan, no? Okay, so that's it. Yung moment capacity, ito kayang-kaya nyo ito. Meron akong problem doon na you find the moment versus area. I don't think you will have problems on that, no? Moment area curve. Moment capacity curve ang tawag doon, no? Ang ibig sabihin, you just plot the moment versus the capacity, moment versus the area of AS. Okay, so this is the moment capacity or strength curve. Okay. Okay, so ito, madali lang i-plot ito. Wala kayong magiging problema, I think, dito. So these are witness derivation, and that's it for our lecture last time. So any other concerns you want to raise now, please feel free to ask before we proceed. So by the way, for the benefit of those who are again not around last time, I'm using a MathCAD platform on my program just to facilitate the computation. So if you want to study MathCAD, it's a very easy programming and interactive platform in math. So shinare na ata ni Alan yung uh, ano ba 'yon? Installer ba, Alan, ang shinare mo sa kanila?
Installer.
Okay, so please feel free to download it and install it in your laptop. Now, if you know programming, other programming language, no problem with it because um, pinakamadali na yung ano yung yung MathCAD. So kung may alam kang mas matindi, it's good for you, no? Yung Excel medyo okay din kung kabisado niyo rin. Okay din siya. Kaya lang mahirap lang i-manage yung Excel. Kung not if you do visual a basic macro interpreter, no, in Excel. Okay, so walang question. So we can proceed maybe on our next lecture